Okay, so let's start. I hope all the students have joined. Okay. The screen is visible, all of you? If the screen is visible, all of you? Okay. So the last time we had discussed about the infix, prefix, and the postfix. So what are the methods you follow when you want to convert any things into a infix to postfix? Which are the steps you follow? What are the steps you follow for the infix to the prefix or infix to the first postfix? Which are the steps you follow? A stack method, there are one method, okay, a kind of a tabular method. In that also you are using the stack only. But which are the rules for the reverse Polish notation? Let's suppose the two priority cannot able to set together. And then another rule is, if you are there anything in the bracket, you can pop it out from the bracket and put it on a, let's say, a symbol over there. And then the lowest priority cannot able to accept, sorry, highest priority cannot able to accept the lowest priority to put into the stack. So there are the rules we had learned. Let's suppose if you want to convert infix into prefix using the tabular method. So what are the first step you need to follow? What are the steps you will follow? What are the things you need to change over there? Convert, reverse the infix. Very good, Jason. First reverse the infix notation and then convert, apply the same method to the postfix, and once you get a postfix, change it into a, again the reverse the pattern, you will get a prefix. Okay, very good. So in this now, today we are going to discuss about these things. This was like a last topic we'll discuss, because if I'll teach you this much of things and once you complete the third semester and again if you start fourth semester, might be you'll forget the thing. Okay. So here explain the instruction format with an example. So what do you call the instruction format? Okay, so instruction is normally made up of a combination of operational code and somewhat the specifying an operand, most commonly by its location or its address in the memory. It's obviously that an instruction is made up of a mode, whether it's an indirect or direct mode. What is an opcode? That means and or subsection or add with a carry or any mode. And in an operand, it might be address or it might be the value of a register. So this is nothing but we call as an instruction format, from which we decide that the instruction format must be of 32-bit, the instruction format must be of 14-bit, 16-bit, any bit over there. Okay. Now, a computer may have instructions of several different lengths containing the varying the different number of addresses, obviously. Now if you are using a 16-bit computer and when you upgrade it to the 32-bit, the instruction format will change. The number of instructions will also change. Okay. So that is what we have. How many types of format over here? We have a single accumulator organization where we have only accumulator to be performed operations, or when you have a different format which have a general register organization where we had given in a computer architecture with a different number of registers, so that can able to use or can able to perform the process faster compared to the single computer organization. And here we have a stack organization. Let's suppose 6 registers if it is given and they are not being used, because while running the program, let's suppose all the 6 registers have been used. So where you will store your temporary data? So if we have architecture which also have a stack organization, that will prefer most. The reason is you can able to store the temporary data and you have a more number of registers to be stored the data for a temporary purpose. Okay, clear this thing? Understand the three organization: a single accumulator organization, a register organization, and the stack organization. Why we have three different organizations? Is it clear, all of you?
Yes, sir.
Okay. Now, coming to the single accumulator organization, let's suppose consider you have an organization, your computer, or a made up of a single accumulator. So obviously, all the operations are performed with an implied accumulator register only. It is possible because in arithmetic and logical, in the lab also we had seen that all the things we are doing with respect to the accumulator only. Okay. So here, if you wrote an add x, so there is a no registers are there. That means from whom it will add. Obviously, that will be a memory location. X is nothing but I can write like the X means anything. So what does it mean? That data will be added with an accumulator and answer will be stored in accumulator. This is what we call single accumulator organization. There is a no other resistance, only a single accumulator register is there. So the doing the addition with the register is not possible. So what do you mean by this? X over there, let's suppose if I write 20, so memory address 20, it will go to the 20 address. What might be the data? Let's suppose 10. 10 will be added with an accumulator. Answer will be stored in an accumulator. This is what we call single accumulator organization. Okay, clear all of you? The thing is clear all of you? Okay, now this is what example is already given over here. So I have X, that is any address, on that address 20. What happens? Accumulator plus memory address and the data will be stored in an accumulator itself. Okay, let us go to the general purpose register where we have accumulator also and we have a register also. So in that format, what will let's suppose I wrote like this. Now memory, sometimes the memory is also concern for us and not a concern. The memory also is a part of an instruction, or register is also part of an instruction. So what I'm doing over here, I have the R1, R2 and the R3. So what happens over here during the R1, R2 and R3, the R1 will be added, R2 and R3 will be added and answer will be stored in R1. So here like this. So R2 plus R3, answer what you got will stored into R1. Let's suppose if I write this two only, it is possible because register, reference instructions are there. Okay, we have the registers. So here what happens? R1 will be added with R2 and answer will be stored in R1. If I let move R1 comma R2, so directly the R2 will go to the R1. What if I write like this? What is the answer will get? If I write like this, write down the answer in the chat box. Very good. The data from memory location will add it with R1 and data will go to the R2. Okay. So very good. So this is how we can able to write the data or write the things or write instructions using the general, if we have a general register organization architecture. Okay, fine. Let's suppose we have a stack organization. That means we don't have a register, we don't have accumulator, only the stack organization if you have. And obviously, you cannot able to use accumulator, you cannot able to use register. Then no need to write these things. Add R1, X. No, it is not possible because we don't have registers. You cannot able to write like this also. Add R1, comma, R2, comma, R3. You cannot able to write. You don't have the registers. So how will you write this? Then there is only one operation possible. Push, pop, only add, only multiplication, only division. Like this you can write. Let's suppose if I have this data, two data has been pushed over here. So like push X. X means which location you need to push your data. Okay. Then only add. So once you push the data, addition of these two will get 3. Okay. So this is what we call stack organization. Is it clear, all of you? All the students, the EC students? Yes, Parth, Nandini, Mahesh. Vaibhav. Okay. Now let us look at the types of addressing instructions. See, these are the very much important question they are asking over in the due exam also. The type of addressing instructions. Okay, so there are the 3 types of addressing instructions we have. Memory address for 2 operand and 1 destination needs to be specified. So we have the 2 operand and 1 destination need to specify, and that's why we call it 3 address instruction. So coming to this, add R1, R2 and R3. Which is the 2 operand in this and which is the destination? Which is the 2 operand and which is the destination? R1 is the destination. What about the R2 and R3, Jaishankar? They are operand. Okay, from where we need to read the data. Okay, so this is what? The memory address, this one, 2 operand. So this is R1, R2 and R3. So memory address of R2, memory address of R3 will be added together and the data will be stored in a R1. Okay, so there's a 3 address instruction. Register name, 3 address instruction. Okay. So the 2 address instructions where we have 2 address registers or 2 memory locations. Here you can write like this also. Here you can do like this also. This is the addition of register. This is the addition of memory location of that content. So what do you mean by this first of all? Let's suppose consider R2 is a 10 and R3 is a 11. So I have the memory in which I have the location 10 and 11. On that the data is 50 and 60. So when I write MR2, so it will go to the R2. What is the location 10? So again it will come back. What is the content? 50 will be added plus memory location of R3. Again it will go to R3. What is that? 11. What is the data? 60. 60 will be added and then it will be stored into R1. Okay, this is what we call 3 addressing. If it is directly R1 and R2, if you want to use register, add R2 and R3 the data and directly the data will go. Okay, this is what we call indirect addressing modes. Okay, so this is a 3 address instruction. When you talk about 2 address instruction, okay, either it might be 2 register or it might be 2 memory locations are to be specified, and there is a first, like here, if I write like this. So what is this? MR2, if I am considering the memory location, plus it will add with R1 and the data will always be stored in R1. This is what we call 2 address instruction. Is it clear, all of you? Is it clear? So this is what. Okay. Let's suppose one address instruction. So it's like a single computer accumulator organization, remember. Okay. So what we'll do over here is to use the accumulator register for all the manipulation, only accumulator only. No other registers are there. Add X. Okay. No other registers. It will only add the memory locations with the accumulator and answer will be stored in the accumulator only. So this is the memory address. No registers are there. Okay. No X are registers. Memory address plus accumulator and answer will be stored in the accumulator. Zero address instruction. That means no addresses. That means we need to use a stack operations or push or pop. So what I'll do, stack means push 3, then push 4, then do the AND operation. 4 plus 3, it should be 7. This is wrong, okay? This is 7 will come over here. There is no multiplication. That means addition of 4 plus 3, if you write only add, what might be the stack? They will be added together. This is what we call zero addressing instruction. So we have 3 addressing instruction, 2 addressing instruction, 1 and then 0. Remember these things. Okay. I'll ask you the program to be right. Let's suppose I have this thing a plus b multiplication c plus d. I have the instruction add, subtract, multiplication, division. Okay. Load, store, push, pop, and move instruction to transfer the operation. What I have the data. This is the memory location. ABCD, ABCD and X is a memory location on which you have the data 10, 20, 30, 40 and results. That means what you need to do, you need to add a plus b to d, multiply both and then answer stored into the X. Okay, using the 3 address instruction, to 2 address instruction, 1 address and 0 address. Okay. First for 5 minutes you try it by yourself and then will tell you. For example, look at over here. 3 I am telling. 2, 1 and 0, do it by yourself. See here. What's the first thing I need? Equation is a plus b into c plus d. First I need to take this data, add with this data, stored into some temporary register, take this data, add with this data, what the answer I got, do the multiplication of both and answer again what I got, I need to store into X. This is the concept I need to apply. Okay, so what I am doing, let's suppose consider add 3 address instruction. The memory location of A, memory location of B, that means 10 and 20 will be added and it will store to the R1. C and D, the memory location are added, stored into R2. Then the multiplication, so MUL R2 into R1, answer stored into X. That is the memory location X. Okay, clear all of you? Same way you need to write for 2 and 1. All of you write it down. Try by yourself, use pen and paper to solve the problem. All of you. Uh, Sorry, the net disconnected. That's the reason I just disconnected from the lecture. Did anyone got the output? Like how you write the program for the two address, one address, and zero address? Anyone can write in chat box. Am I audible first of all? Am I audible, all of you?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So better you just writing down how you write the program for this two address and one address and zero address. Better you write it down in a one line. Jason, if you are writing in a send message to everyone, like in a chat box, when you want to go to the next line, shift and enter. Okay. Okay. Let's go with the two addressing mode. So what I'm doing, I'll go to this location, the memory location. I'll copy it to the R1. I'll take the memory location of B. I'll do the addition with the R1 now. Okay, so R1 and side by side I written also the comment. Okay, then I'll store it, like take the C, same do the add and store it to the R2. Now the data is in R1 and R2. Now I need to multiply that two data and I need to store into R1. Okay, R1 multiply R2, that is two addressing and then last. Clear the two addressing? All of you? Clear, all of you? Ask if you find any doubt in the program. Same way, consider you have only an accumulator and the memory address. So how will you do that? Okay, so you need to take a temporary register to store the data when you're using the single addressing mode. Okay, so write down the instructions related to single. The same concept, a plus b multiply c plus d using single. Okay, for the single organization, wait, network is disconnecting continuously. Am I audible, all of you? Hello, am I audible?
Yes, sir.
Yes, sir.
Yes, sir. You are audible, sir.
Okay, if the network is connected, am I audible, all of you?
Yes, sir.
Okay, so today just network disconnectivity is more. So this is a one address instruction. So what we are doing, when you write an LDA, data from that location will come to the accumulator. Add B, okay. So store the data, again load C, add D, multiply and then store. So this is a single addressing mode, okay. And last zero addressing mode. So we don't have any accumulator or registers, only we have the stack location. So how you can do, you need to take an temporary stack operation. So here what you are pushing the data A, that means what might be the data of A, we'll put it into stack. Okay, what is the data we have? 10, 20, 30, 40. So what we'll do in a stack, we'll put 10, then we'll put 20, we'll do the addition of this, we'll get an answer 30. Okay, then again we'll push the data the C 30, again we'll push the data 40, we'll add this to what will be the data as 70, and here already the stack we have 30. Then after addition I'll apply multiplication. Okay, so I'll do the multiplication of this two, and the answer what I got, that will be in the last stack, and I will pop it to the X location. So this will go to the X location. Is it clear, all this difference? Is it clear, all the difference? The 0, 3, 2 and 1. Just have a look for this 5 minutes, and then if you have any doubt, you can ask the question. Okay, so we'll put it up to here, and all the best for the exam. We'll not teach the next of the new things, because if I'll teach you and after the exam when you come it back, I don't think so you will get it, memorize all the things. So till 5 unit and 5 is completed almost 75%, the 25% are still remaining. So we'll complete it within the next lecture till 5 unit, and rest of the 5 units we'll teach after your you'll learn after your exam. Okay, so all of you just write down the attendance in the chat box. Enrollment number first, the EC students. Vaibhav, we'll meet at 2:30. Okay, Vaibhav, Mahesh, Parth, just for 15 minutes
Yes,
we
sir.
need to discuss. Okay.
Okay, sir.
Okay, and Nandini is there. Divyas is not there. Okay, fine. Then rest of the students, regular, write it down. Dirga. Okay. Okay, those roads they can do. Okay. Those roads they can leave. Okay. Can I? Okay, anyone is remaining to write attendance? Abhishek, Ankit, Karnavi, and
Hello, sir. 113. Hello, sir.
yes, Abhishek.
Sir, I am not able to write my attendance. Sir.
Tell
Can you
me.
please
Tell me.
help?
Mhm.
Yes, sir. 113.
Okay, I wrote it down. Okay, you can leave.